systems. I hope you enjoy the presentation. Over to you, Katarina.
Thank you, and I will hand straight over to Rachel, who will do the start of the presentation.
Right.
Hi everyone, welcome to our presentation today. It's entitled Enabled Funding Access to Digitally Enabled Chemical Process Capabilities. My name is Rachel Squires. I'm a Business Development Manager at CPI, and Katarina Rodrig is the Principal Scientist at CPI. So I'm going to give you a brief introduction to CPI and also to our latest ERDF funded program called Prospect. And then Katarina is going to talk a little bit more on the technical side. So at CPI, we help companies to develop, improve, scale up and commercialise new products and processes. We're based in the Northeast, in Durham, in the main, but we do work all over the country and indeed all over the world. CPI is part of the Catapult team. So the Catapult system is funded by the UK government, and there are a number of different arms to the Catapult structure. We're part of the high value manufacturing Catapult, along with companies like WMG, MTC, the National Composite Centre, and one or two others as well. So that's where we fit. So we're funded to provide support to UK companies in improving their process and product development. So we help to deliver, de-risk and accelerate concepts into successful products, and we sit in that innovation middle ground between research and invention and then the commercial marketplace. So from a TRL level point of view, technology readiness level, we're somewhere between roughly 3 to about 7, and that's where we do work in the main. So we help all sorts of industries develop high value products and processes within their marketplace. And we work with a very broad range, from pharmaceutical companies to agri-tech to FMCG, energy, aerospace, all sorts of companies. So there's no limit to the sorts of companies we can support. And we have core expertise and capabilities in an ever-expanding range. So we have biotechnology, biotherapeutics, formulations and materials, pharmaceutical processing, photonics, printed electronics, flexible hybrid electronics and digital capabilities. And most of these are based within Durham, although our new Medicine Manufacturing Innovation Centre that we're in a partnership with is up in Strathclyde. So most people know us in terms of our innovation services for our industry relevant expertise and assets. So many people are used to the idea that actually we provide product development, proof of concept and scale up services, utilising equipment, state-of-the-art equipment that is often difficult to access through commercial means. We do also provide expertise in securing funding for partners and clients, and knowledge and application of the innovation processes within themselves. So there's a lot of business consultancy and support there as well. So we work from proof of concept and scale up, enabling ideas to be developed before you approach stakeholders, investors, etc. So that's quite a nice process for companies who are wanting investment to be able to prove that they've done their due diligence around their proof of concept. We help to reduce risk in terms of product development. So we help people to refine and ensure that technologies are as effective and productive as possible before further investment. And we decrease time to market by providing the demonstration assets and the industry expertise. We work with markets across all innovation cycles, from proof of concept to commercialisation. And these can be very short projects, a year or less, sometimes even months, right through to very long partnerships that can take up to 12 years to process. Often the the shorter projects are within the digital and ITC. The much longer sorts of projects are within pharmaceutical and medtech type companies, where there's an awful lot of trial work and refinement to go through in order to get products into a market space. So we've got something to offer for everybody. The CPI doesn't just cover one or two opportunities for one or two types of companies. We're very broad ranging. We can work with very large corporate companies, giving them capability that they aren't really able to access in a very agile manner. We can support SMEs in their product development, so giving them access to capability that they wouldn't otherwise be able to utilise. We can support universities through showing impact from their research, but also from subcontracting capabilities. And we can help investors find companies and assess those companies to see their suitability for further investment. So we've just launched a new project called Project Prospect. Those of you who've heard us talk about these ERDF projects before will be familiar with the concept, but for those of you who aren't, the European Regional Development Fund provide access to state aid funds through development work that CPI can do with SMEs. So I'm going to talk a little bit about Project Prospect now. The project is focused mainly around using liquid and powder handling formulation challenges. So anybody who is regularly using powders, liquids, it could be mixing, it could be granulation, it could be products not moving smoothly through the system. So this could be food and drink, it could be personal care, cleaning, coatings, specialist chemicals, basically any company that is refining a product or a process that is liquid or powder based. And this project is quite long ranging. As I say, it's only just started, so it ends around December 2022. And we can provide all sorts of support, from flow modelling to digital twin to formulation chemistry to large data analysis. So we can use our expertise around computational fluid dynamics and particle modelling. We can do digital twin work, looking at the manufacturing process within complex powders and liquid process analysis. We can create new formulas. We can do stability testing. We can look at challenges with mixing and granulation and batch to continuous flow purposes. And we can also collect huge amounts of data through our specialist sensors in our kit. So this ERDF project Prospect is 100% funded, so it utilises state aid. If anyone out there wants to think about accessing this project, by all means speak to us about state aid if you don't understand what that means, because it is quite simple and I can explain it in more depth. But essentially what the 100% funding means is that we don't require any direct financial investment from the companies who take part. So that makes our projects relatively unique in the funding arena. So we can work with SMEs within the North East LEP. So that covers basically Northumberland, Tyne and Wear, County Durham, basically if your bins are emptied by Durham Council. Excuse my cat in the background. And to be an SME, you must have less than 250 members of staff, and you have to have less than a 50 million yearly euro turnover. So we can work with any company who fits within that remit. There is an application process for this particular project, and we're quite happy to talk that through with you and go through it with you in more detail. So if anybody wants to talk to me about joining the project, there will be some details at the end of Katrina's presentation. or you can ask questions in the discussion. So I'm going to pass over to Katerina now so she can talk about our technical capability.
Thank you, Rachel. Yeah, I'm going to talk a little bit about the technical capability that we're using to deliver these projects. And when we first started on let's say CPI's digital journey and supporting customers, we identified a need within industry for a better understanding in two areas, really. One is the enabling a more predictive product design to decrease the time to market. And the other area that we identified is to enable faster process innovation. So we developed and built a number of test beds and the underlying digital infrastructure that then enables us to address these challenges. And I'm going to talk to you about some of these test beds and CPI's capabilities in these areas to sort of give you a flavor for the types of projects that we can do in the digital space. And CPI has capabilities which can be broadly categorized in these four areas that you can see here. And they are all used across all the sectors that Rachel just mentioned before. The first one, the digital design one, that includes mainly mechanistic modeling for fluids, for example, via computational fluid dynamics, and also mechanistic modeling for powders through, for example, discrete element modeling and other modeling capabilities. And then the second category here, the smart factory, that includes things like advanced process control, so statistical models, and also process analytical technology, and also combining the mechanistic models from the digital design piece with our statistical models to then create digital twins. And all of these methods are really only useful if you've got data. So it's absolutely crucial to have the right data and the right sensors in your process. And CPI is working in the areas of cost-effective and printable sensors, which can be used across sectors. And we also use in this fourth category a range of digital tool sets which can be used across any of the other categories. So that includes things like artificial intelligence, machine learning, 3D printing, and so on. And in the next few slides, I'm going to talk a little bit more about the smart factory and some of the test beds that we built in this area. So the first one I'm going to talk about is a test bed for complex liquids manufacturing. And that's really made for de-risking innovation in the area of formulation. And it's got three main purposes, if you like. The first one is to look at scale up and scale down and de-risk this process for companies. The second one is to use it as a flexible test bed for developing and validating process analytical technology and other sensors. And the third main purpose of this is to looking at implementing and developing advanced process control methods. And all of these three areas, they are available as part of the ERDF Prospect project that Rachel just mentioned before. So they are fully funded projects in these areas. And we've got a second project, which is called Digital Innovation Hub. And that's more focused on these digitally focused purposes of this test bed, if you like. And I'm going to talk a little bit more about this project in a moment. I just wanted to show you the general setup for this particular pilot plant. And we've got a very similar setup in the powder space. So we're not limited to liquids. We can also work with powders, for example. And the setup is split into three parts, which are then combined. The first one is a set of scale mixing vessels ranging from 1 to 1,000 liter. And they are connected by a number of flow loops, which have a lot of sensors for pH, conductivity, density, and so on. It's all fully temperature controlled. And it's a bit like a big Lego set. So you can set it up and configure in any configuration you like, really. It's very, very flexible. And because it's so flexible, we can add a lot of process analytical technology instruments or PAT instruments in lots of different configuration. And our, let's say, permanent set of PAT instrument that we've got is we've got an inline particle sizer called FBRM and an inline microscope. We've got an at-line laser diffraction instrument, which is effectively like an at-line version of the Morven master sizer. And we've got an inline viscometer as well. And these two parts of the pilot plant, they are connected by our digital infrastructure. So we've got a very sophisticated, very clever advanced process control software. And that's really taking the data from our PAT and the data from our scale-up vessels and the flow skids and combines it and allows us to do some data analysis and model building, so we can then have advanced process control on our processes. So it's very powerful, and I'm going to show you later how it works. Let me just quickly talk you through the Digital Innovation Hub, which is a very new project. And what we are trying to do there is building 2 test beds, open access test beds, which will allow the rapid development of advanced process control tools. And we decided to focus on 3 different tools. The first one is the chemometric calibration model development. And that means we can build mathematical models to predict properties of new samples. So if you think about, let's say, moisture content of particulates, we can build chemometric models if you've got, for example, heavy interference from other species in there. So these chemometric models really help you to predict and understand your spectra there. The second tool that we are going to use is soft sensors. And they are a way of using data from existing sensors to make inferential measurements of properties which are otherwise either hard to measure or impossible to measure. One example could be when you think about viscosity. If you measure the pressure drop is broadly dependent on the geometry of your flow loop and the rheological properties of your liquid. And if you then measure your pressure drop in a given geometry, you can then infer the viscosity of your liquid, which is very useful. And you can use these 2 tools to then implement model predictive control, and that then allows you to predict the future behavior of your process based on historic data. And it can then automatically correct process parameters to drive your process in the direction of the targets that you want for your products. And the implementation of all these tools, they will allow you to go to dynamic manufacturing processes, which is very, very powerful. And as part of this project, we do have fully funded project opportunities, very similar to the ERDF project that Rachel was just talking about. And I said before that we are building 2 test beds that we're going to use for the project. And the first one is a flexible probe station on our high throughput equipment. So that will allow us to measure a huge number of samples in a relatively short amount of time with different PAT instruments and probe heads and sensors. Our initial sensor is an NIR sensor, and that will allow us to very rapidly build chemometric models. The second test bed is using the pilot plant for liquids that I've just shown you before, and we will use that to develop a methodology for the rapid development of soft sensors for example, viscosities. And the 2 test beds, they've got different applications, and projects could, for example, be on the high throughput probe station. That could be, for example, measuring a number of samples and building a chemometric models for a product or a raw material, for example. Or it could be that you've got a sensor or a new PAT instrument that you wanted to test, so we could do that. And a likely timescale for projects in this test bed would be February or March next year. And on the second test bed, the soft sensor development, and also that will be used for the MPC development. Example projects could be to develop a soft sensor for your application, for example, for viscosity, or again, testing sensors and comparing their performance in different configurations with our existing sensors or existing model systems. And a likely timescale for these would be in January or February next year. And I just want to show you 2 very short case studies to give you a flavor of how that could really look like and how it looks like in the lab. So the first one is about real-time measurements and process control of a simple emulsification process. And what we wanted to do is we wanted to control the rheology and the droplet side because they are key formulation measures in processes like this. And we used our inline sensors for viscosity and particle size, but we could have also used soft sensors for the development of our model predictive controller. And we used our mixing vessels and our flow loops, just like I showed it to you before. And then you can see here a view inside the vessel, so you can see the mixing process. And these two metal cylinders that you see on the top right and the top left, they are our inline microscope and our particle sizer. So they are directly in the vessel, very close to the mixer, and we get real-time data about our process, really. And then if you look at the inline microscopy, you can see that you get droplet sizes, you can see how your process develops, and then you can use that to build your control model. And here you can see how it looks in real time when we collect the data. So you can see on the top left here our SCADA system, on the bottom left the data collection, and then on the right you can see how the PAT instruments are collecting the data, and how our droplet size distributions are collected, and so on. And then we use this to really control the process to the set points that we set, and that's working really, really nicely. And the second case study that I wanted to show you is a crystallization reaction. And what we've done here is we used a rat-race reactor, added our inline microscope and our inline particle sizer. And you can see in this video that the bottom of the inline microscope, and you can see this probe window here. And you can see that all the particles are going past the probe window. And then if you then look at the video, the particle size distribution, you can see what's happening in the process. And what we've done is we looked at this crystallization reaction at different temperatures. From 30 degrees, we cooled it down to 50 degrees. And then you can see when you look at the video, at the beginning, we don't have many crystals, and they are quite small as well. And as we cool down, you can see more crystals, and they also grow bigger, as you would expect. And then we can quantify this with our particle size instrument. And again, we can see the crystals growing, and we can also see the concentration of bigger crystals going up, which is exactly what we expected. And what we can do with this kind of measurement is, we can show that we can actually measure a lot of different systems, and we can also it can also help us to understand how exactly the crystal growth depends on the temperature to control it and to make it as efficient as possible. So it's very, very powerful to being able to do that. And with that, I'm going to hand back to Rachel.
Thank you, Kat. So as I mentioned earlier, if you are interested in accessing any of these technologies, either through one of the projects that we've talked about today or another project, or if you're outside of the Northeast LEP and want to discuss how you might be able to work with CPI, by all means do please come along to our booth and have a chat to us. Also, you can email me at rachel.squires@uk-cpi.com, and I'm quite happy to answer any inquiries that you have. If you've got any technical questions, I'm sure you're also welcome to email Kat, and her email address is at the bottom of the screen there also. So yes, by all means, if anyone's got any questions, we'll hang around so people can ask anything that they want to. Otherwise, hopefully we'll see you at the booth in a short while. Thank you.
Right, well, thank you very much, Katarina and Rachel. That was really interesting, really showcasing some powerful process development technology there. So I'm sure that will be of interest to people. So as Rachel said, please visit the booth to ask more questions, or if you have any more questions now, please ask them via the discuss button, and I'll put those questions to the CPI people.
Thank you.
Don't seem to have any questions, I'm afraid.
That's okay. I'm sure that we'll be able to speak to people if they come along to see us.
So please go and see Rachel and Katerina at their booth. So thank you very much. Nice to meet you.
Thank you. Have a
Bye.
good afternoon.